Good morning, Seeders. In this video we are going to go through how to answer questions about nuclear decay. If you find it useful, don't forget to subscribe. So in question 1 we have polonium-210 is a radioactive isotope that decays by emitting alpha radiation. Which is the correct decay equation for polonium-210? In this particular question you don't have to do any completing, it's just asking you to pick the right one. But it's quite useful to point out one of the things that the exam board does. Sometimes they are not really bothered what the product nucleus is, so they just use an X for that particular nucleus, and I wouldn't want that to be a surprise in an exam. What the exam board is really interested in is whether you understand the numbers. So we have polonium giving off an alpha particle, which is a helium nucleus. And as you can see, a helium nucleus has a mass of 4 and an atomic number of 2. If a polonium nucleus is emitting a helium nucleus or an alpha particle, then we would expect the mass to go down by a corresponding 4 and the atomic number to go down by a corresponding 2. So if we have a look at this first equation, we can see the mass of polonium is 210, but it goes up to 214, so it cannot be equation number 1. In equation number 2, we can see the mass does indeed go down by 4 to 206, but the atomic number goes up by 2, so it cannot be equation number 2. So by a process of elimination, we know that it must be equation number 3, but let's just check it anyway. So I've got the mass of polonium 210 going down to 206, and the atomic number going from 84 down to 82. You can do a double check as well. You can say, well, 206 plus 4 gives us 210, and 82 plus 2 gives us 84. In the next question, we have an atom of bismuth 212 emitting an alpha particle again. The atom decays into an atom of thallium. An alpha particle is the same as a helium nucleus. The symbol below represents an alpha particle, so it helpfully gives you a reminder of alpha particles. The equation below represents the alpha decay of bismuth 212. Complete the equation by writing the correct number in each of the two boxes. So this is a much more typical question where you are given all of the symbols of the nuclei, you're given the symbols of the equation, you are given some of the numbers and expected to complete two boxes. So I've got bismuth 212 giving off an alpha particle, so the mass we would expect to go down by 4. So all you have to do is write in the new mass of the thallium. We have bismuth with an atomic number of 83 giving off an alpha particle with an atomic number of 2, so we'd expect the atomic number to go down by 2. In the next example question, we have a krypton nucleus decaying into rubidium, nucleus, by emitting a beta particle this time. Complete the nuclear equation for this decay by writing the missing number in each box. So again, a typical nuclear decay question where we are simply filling in mass and atomic numbers in the boxes. In this case, the krypton has given off a beta particle, and we can see that the mass of the beta particle is 0. Therefore, when the krypton gave off the beta particle, if there's 0 mass associated with that, there will be no change in mass. So the mass of the rubidium is 85, the mass of the krypton must have been 85 as well. And we can check it by saying 85 plus 0 equals 85, so we've got a mass of 85 there. Now you may remember that in beta decay, a neutron spontaneously turns into a proton, giving off that beta particle. Therefore the atomic number actually goes up by 1. So we have rubidium 8537. We can check by saying 37 plus -1 gives us 36. In our next example, we have a decay equation. So in our decay equation, we can see the fission of uranium-235. So we have The following nuclear equation represents the fission of uranium-235. We can see the neutron being added to the uranium nucleus, and then the nucleus's mass will go up. Fission will take place, giving us barium, krypton, and 3 more neutrons. We come to the question. An isotope of barium is barium-139, 139. Barium-139 decays by beta decay to lanthanum-139. Complete the nuclear equation that represents the decay of barium to lanthanum. So again, we have been given the symbols, we've been given some starting points for the numbers. This time, interestingly, they haven't given us the symbol for the beta particle. So we're going to put that in. So you can either use a lowercase e, because of course the beta particle is a fast moving electron. You can also use the beta symbol. I'm going to complete the answer over here using the lowercase e. Now, from the previous question, and also from your brains, you should know that a beta particle has a mass of 0 and has an atomic number of -1. We can see that the mass of the barium hasn't changed. We can take the atomic number of the barium from up here. So I've got barium 56. So we're just going to put 56 here as the atomic number. And we remember that a neutron turns into a proton, therefore the atomic number will go up by 1. We can double check by saying 57 plus -1 gives us 56. In the final question, I seem to have lost a bit of focus there. There we go. We have polonium again. So I've got polonium-210, a radioactive isotope that decays by emitting alpha radiation. Complete the decay equation for polonium-210. So we have 210 giving off an alpha particle which has a mass of 4. So we're just filling in the boxes for the numbers, and the mass will go down by 4 to 206. We have an atomic number of 84 giving off an alpha particle which has an atomic number of 2. So the atomic number will go down by 2 to 82. We can check by saying 206 plus 4 gives us 210, and 82 plus 2 gives us 84. That will do for today, Seeders. I hope the video was useful. Do subscribe if you did find it useful. This is Mr. Rolf signing off.